In this presentation, we're going to talk about the gas furnace sequence of operation. Now, what do we mean by sequence of operation? Basically, we are talking about from the thermostat's call for heat, what happens internally in the furnace throughout the entire heat sequence until the furnace shuts off. Why do we care about this? Because if you don't know how the furnace is supposed to be operating, there is absolutely no way you can troubleshoot the furnace and find out what's going on. The sequence of operation is the order in which the call for heat, the ignition, the heating or blower operation, and the shutdown all work. It depends on the type of the furnace, and every manufacturer may have some different timings, but it still follows the same pattern. So let's start off with the most easy and simplest type of furnace. It's the standing pilot. A standing pilot system is one that has a constant pilot light. If the pilot light goes out, it has to be manually reset and lit. The heat from the pilot light creates voltage on a thermocouple, which keeps the gas valve operational. So when we're talking about the sequence in here, we're assuming the pilot light is lit. Okay, if the pilot light is not lit, none of this is going to work. So the thermostat calls for heat. It sends 24 volts to the gas valve. The gas valve opens and allows gas into the burner manifold. The gas ignites and starts heating up the furnace. The furnace heats up to the fan cut-in point, usually on the combo fan limit switch, and the fan control turns on the blower. This provides heat to the space. Once the thermostat opens, the RW circuit, the gas valve closes. The blower continues to run and cools the furnace. Once the temperature of the furnace has dropped, the fan control opens and the blower shuts down. If the high limit opens any place in this sequence, the gas valve shuts down and the blower continues to run. This is critical. If the high limit opens, the gas valve shuts down, but the blower will continue to run. That's a critical troubleshooting item. The next type of furnace is the spark ignition furnace. Spark ignition or intermittent pilot systems are when the pilot light is shut off after every call for heat. On most intermittent pilot systems, there's also a draft inducer, but not all of them. So we have the atmospheric burner type. That's a non-draft inducer. Okay, the thermostat calls for heat. It sends 24 volts to the control module. The control module sends a 10,000 volt shock to the pilot assembly. The control module sends 24 volts to the PV terminals of the gas valve, opening the pilot valve. PV, pilot valve. Pilot ignites and heats up the pilot sensor, creating a DC current for flame rectification. Once the control module senses flame, it sends 24 volts to the MV terminal of the gas valve, opening the main valve. Once the call for heat is complete, the thermostat opens the RW terminals and the control module is shut off. This in turn de-energizes the MV and the PV terminals on the gas valve. This induced draft type the next type is the induced draft. Okay, now this type has a draft inducer that has to be running before the call for heat can continue. Okay, this uses a draft inducer motor to move the combustion air through the furnace. The thermostat calls for heat, sends 24 volts to the draft inducer relay, which closes and turns on the draft inducer motor. The draft inducer motor starts and closes a low pressure switch, which proves draft. The low pressure switch allows 24 volts to go to the control module. The control module sends a 10,000 volt spark to the pilot assembly, also sends a 24 volts to the PV terminal of the gas valve. The control module uses flame rectification to sense the presence of the pilot. The pilot ignites and heats up a pilot sensor, creating DC current for flame rectification. Once the control module senses flame, it sends 24 volts to the MV terminals of the gas valve, opening the main valve. Once the call for heat is complete, the thermostat opens the RW terminal and the draft inducer motor shut off. The pressure switch opens and breaks the current flow to the 24 volt control module and gas valve. This in turn de-energizes the MV and the PV terminal on the gas valve. Okay, now here's a critical thing. If you're ever asked or have to follow a draft-induced system through, the thermostat controls the draft inducer. Okay, it does not directly control the ignition module. We have to turn on the draft inducer first. The pressure switch controls the ignition module. Something important to remember. The next type is the draft-induced hot surface ignition. The director hot surface ignition type furnace uses a glowing red hot surface in the main gas stream to ignite the burners. There is no pilot light. The ignition sequence is very much like the spark ignition minus the pilot. There is always a draft inducer on these models' furnaces, so you don't have these without a draft inducer. The thermostat calls for heat. It sends 24 volts to the draft inducer relay, which turns on the draft inducer motor. The draft inducer motor starts and closes a low pressure switch which proves draft. The low pressure switch sends 24 volts to the control module. The control module sends 120 volts to the hot surface igniter, causing it to heat up and glow. This takes around 90 to 120 seconds. The control module then sends 24 volts to the MV terminal, that's main valve, of the gas valve, and gas flows into the burner manifold. The control module has the hot surface igniter on one side of the burners and a sensor on the furthest burner tube. So we need to make sure that all of the burner tubes have ignited. Once the gas ignites, the flame sensor on the other side senses this flame through flame rectification and shuts down the hot surface igniter and keeps the main valve open. If no flame is sensed in 3 to 5 seconds, the ignition sequence terminates, closing the gas valve and either locking out or trying again. And again, there's going to be pre- and post-purge cycles throughout this whole thing. Once the call for heat is complete, the thermostat opens the RW terminals and the draft inducer motor is shut off. The pressure switch opens and breaks the current flow to the 24-volt control module and gas valve. This in turn de-energizes the MV terminals on the gas valve. Hot surface ignition systems do not need to have a pre-purge, as the 90 to 120 seconds of igniter warm-up solves this. Some systems will have pre-purge and then stop the inducer motor during the warm-up. We're going to talk more about these in the future. So again, just to recap, we have 4 basic types, okay? We have the standing pilot. Those are almost all gone now here in the United States, okay? They're pretty much just about gone. We have the we have the spark ignition with atmospheric type. Again, those are older, and we don't have a lot of those left. We have the spark ignition to pilot with a draft inducer. We still see a lot of those more in the 80% range of efficiencies. Then we have the direct hot surface ignition, which is what we're pretty much seeing on all newer and 90% type furnaces. You have to know what the sequence of operation is before you can properly diagnose and troubleshoot a furnace.